Alright, time to move it. No, not fucking Ling Long, yo. Cool. This last time we were using the arrow operator. So that if we have an object, cool, bro. So that if we have some object action, and this object, a struct, has a pointer in it, not an object, a struct that has a data member that's a pointer, and we have a pointer to the struct. Well, do I dereference the struct, and then inside, and then after dereferencing the struct, use the? I guess I could do that, huh? It would just be kind of ugly. So we could have a struct student, or whatever. Let's just say it is an index. Okay, who cares? But then we have a struct. Let's say a student has a number of pencils, and then we have a struct class. Oh, well, not classroom. Whoops. And it has a student. Class students. Alright, we'll just say class student. Ideally, we would have an array of these, but it's fine. Cool. And if we make a classroom, A3 is the class name, and it's initialized with a student, which is 3, it's cool. We could also say, oh, initialize the student with this and this, but in this case we only have one thing, so we may as well just say, okay, the student gets integer 3, and this is classroom, and then we could have dot class student is 3. Okay, now it's too hot. Oh wait, timer. Till 9:20. And we could have, let's say we have a pointer to a classroom, so a classroom pointer called A3 pointer, and it gets the address of A3. I could do it this way. We could say dereference A3P and then get the class student. Oh wait, hold on. Oh wait, and let's say that it actually gets a well, how would I want to initialize that? Let's say it's a pointer to a student. So let's say that we have a student Jack, and he has 3 pencils, and then this is actually a pointer to a student, and this is pointer to Jack. Or, sorry, this is address of Jack. And then in this case, what are we doing? We're saying okay. We're saying I'm going to dereference A3P and get its class student, and then I can get the pencils through that. So we could actually mix this. Or we could just say A3P, class student, pencils. That way I don't have to dereference it and then get the next and dereference it. And what that would look like is either the mixed version or more likely, dereference A3P to get the class student But we actually need to dereference this entire thing. Like that. Yeah, possibly incorrect, but it's fine. And sure, I could put another one of these here, like that. And now it's happy. Wait, maybe not. The point is we're dereferencing this pointer so that we can get its student, because this is a pointer to an object, or a pointer to a struct. But then we are dereferencing this entire thing in order to get the pencil value of class student. And that lets us get the pencils. Or we could do that, or we could just say this whole thing dot pencils, and it's cool. Or, much more simply, A3P class student pencils, done. Much easier. I don't think it's super common, but in case we have a pointer to an object, then maybe it's cool. I mean, I guess I could see that, right? So if we have a like a character who has a pointer to another character, a pointer to an enemy, we could get it. Yeah, that's a good example, actually. Let's do that. So we could have a main character, Jack, alright? And let's say this is actually a pointer to a target. And we could set it to be maybe there's a target called Goblin and it has 300 health. But now we could say Jack gets the address of Goblin. And then I want to get the target that Jack's holding. So we could say Jack. Oops, hold. Oh, well, Jack's actually not a pointer, but we could say Jack.Goblin. Oops, on dot character target. Dot health, or health to get it. Or we could say dot health, but then it's going to automatically do that. Or we could have a pointer to Jack. So like, let's say there's some object that needs to look at Jack to get the target. So we're passing Jack to, I don't know, something that moves the character around the world. Well, that needs a pointer to the character. So let's say we make a main character pointer called pointer to MC. And we pass it the address of Jack. And I need to get Jack's target somewhere else. We can just do pointer to MC to get the character's target, to then get the health of the target if I wanted, or whatever else we want. Adding white space? Oh, that makes sense, yeah. Like that? Well, it's not bad. Mixing pointers and non-pointers to members. We have a mix. We can see member selection if we have a mix. So we could have like a regular variable that has a pointer variable, or a regular struct that has a pointer to a struct inside it. So we could say regular struct dot pointer to struct, and through that, boom, to get it. That way we don't have to dereference the pointer to struct. So in this case, we have an animal, and it has a string, and it also has a number of claws. Okay, so we could say there's a puma. So we have animal, the name is puma, and we initialize paw to B5. 5 claws. Excuse me. So animal's data member paw is initialized with 5. And paw, that's cool because paw only has one data member. Well, it would have been cool otherwise, anyways. But maybe it has an undefined extra data parameter that we're not, or data member that we're not initializing, and then if we use it, undefined behavior, no good. So we could make a pointer to this guy, and in this case, we could say animal arrow operator to get the paw dot claws. Yeah, there it is. If it's a pointer, use the arrow operator. If it's not, use the dot operator. The nat. Class templates. A separate overloaded function for each set, and that's annoying because it's redundant. It's the same code, we're repeating ourselves. Same code, difference is the parameters. And specifically, it's just their types for a template. All right. Makes sense. Saves the overhead cost of us having to write different versions of the function for the same logic. Yep, already covered templates. Aggregate types of similar stuff. What do you mean? Wouldn't we want the types in a structure to be similar? Really? So we make, so some structs need to have different types. So we could have like I mean, a pair is a good example here. A point could be maybe a vector, and then the vector has maybe a vector needs to have be made with an int, but also made with doubles at some other point in time. Well, now we have two fucking structs. Redefinition of pair. Because Max takes a pair in both cases, but not. Because it's still a pair. Even though what it includes might be different. We only see one object as an argument, and then one return type. That's the whole signature. Nope. The parameters are the same. Identifier is the same, therefore they are the same. Redefinition error. Well, rather, they don't use the return type in order to be differentiated. If they differed in parameter type and return type, we don't give a shit about the return type. Yeah, it's stupid if we have to remember different ones like that. Especially if we want to combine them and mix match. It'd be cool if we could use one thing and then just get the right results. The problem though is how we use that info, because we won't necessarily know that, hey, this one yields a double, this one yields an int. So make a template and then put in some type name stuff, just like we did in the function before. We could do doubles. Oh, I'm so tired. I need some better music. I'll do this one. First and second. Gotcha. So one of them uses template type deduction or argument deduction, I guess, and then another one does the same thing, and then the next one uses an existing one because it already exists. It's a specialization. Yeah. I don't think this is super helpful. Class templates. I mean, maybe, but I mean, for cases where we can have optional functionality, like for a standard optional, where we can actually store, where it's actually an object that stores two different values, then it's cool. But by default, I don't know, if I make a struct for a character, I kind of want to know what all the data types are inside it. I don't want them to be determined by the compiler, I don't think. I mean, maybe. And non-template types, or non-type templates. Is that how that works? Oh wait, duh, it doesn't need a... We create a number container called bucket. Now what happens if we do this? Excuse me. I guess it does need arguments, yeah? Hmm. But not the same type. Maybe non-type tempo parameters don't exist for classes, huh? How has it already almost been 30 minutes? Hmm. Does it really need... Why not just a reference to number container? Oh. So I can't just print it? Hmm. Hmm. template parameter declaration. Mm-hmm. Wait, did I need to specify that earlier though? I don't think I did. No. So this is, I guess, using template deduction. But I could totally say like this. And then I could say this, but we're going to get narrowings, right? Yeah. Oh, this doesn't even have a name, by the way, too. So this would still be double. And then temp. I mean, it's not temp now, but... Okay. Oh, and I guess maybe you do that to specify that, hey, we're creating a different object instead of... I mean, it is a different object, but you're creating it with different parameters. So it's like, hey, we're creating an int struct. Oh, hey, we're creating a double pair. Oh, and another double pair, instead of just leaving it up to the reader to read the arguments. So it instantiates stuff the same way. I imagine we include these in header files then too, huh? Yep. Makes sense. It's not going to redefine it. Alright, I'm going to brush my teeth real quick and maybe I'm going to go to bed. I don't know. I'm just fucking so tired.